Okay, in this video, we're again going to talk about graphing lines when given the equation of a linear relation. In this case, the equation is not in y equals mx plus b form, so it may be more efficient to use a different method to graph, which we're going to call the intercept method. So we only need any two points to graph a straight line, and in this case, what we're going to do is we're going to find the x and y intercepts, mark those points on the graph, and then connect them with our line. So we know that to find the x-intercept, the y value is going to be 0, because at any x-intercept, any point where the line crosses the x-axis, y must equal 0. The y-coordinate will be 0. So to find the x-intercept, all we have to do is set y equal to 0 and then solve. So if I set y equal to 0, I'll have 3x plus 7 times 0 equals 21. Well, 7 times 0 is just 0. So I'm left with 3x equals 21, or x equals 7. So I know right away that my x-intercept is going to be 7, 0. And I can mark that point on my graph. So 1, 2, 3, 4, 5, 6, 7, 0. There's my x-intercept. And I can do the same thing. One thing that I know about the y-intercept is that no matter where it is on the y-axis, the x-coordinate is going to have to be 0. There's no horizontal distance. So I'm going to set x to 0. So I'm going to replace x with 0. And now I can solve for y. 3 times 0 is just 0. So I'm left with 7y equals 21. Y equals 3. So therefore my y-intercept is 0, 3. And I can again mark that point in the graph. And now that I have 2 points, I can just connect again with a straight line using my ruler that extends forever in both directions. And I can indicate that with arrows. So if we have an equation of a line closer to standard form, it may be easier and faster just to use this intercept method rather than rearranging into y equals mx plus b form. But of course, I could rearrange. I could have moved the x over. I think I would have some fractions and some negatives, but I would end up graphing the same line. Sometimes this is called the thumbnail method, because to find the y-intercept, I just cover up x and solve for y. And to find the x-intercept, I just cover up y with my thumbnail and solve for x, which is the same thing as setting y or x to 0. Let's just do one more example. So again, to find my x-intercept first, let's set y equal to 0. So if y is equal to 0, then this part of the equation will disappear. And I'm left with just 4x equals negative 10. So x equals negative 10 over 4. If I reduce that, x is going to equal negative 5 over 2. Graphing lines is one place where I find it's more efficient to use decimals. It might be easier to find the point. So in this case, the x-intercept would be negative 2.50, and I can mark that again on my graph. And then to find the other intercept, because I need 2 points, I'm just going to set x equal to 0. Again, remember that the negative in front of the 2y belongs with the 2y, so when I set x to 0, I'm left with the equation negative 2y equals negative 10. When I divide both sides by negative 2, so y is going to equal negative 10 divided by negative 2, so y equals positive 5. So I could write a little therefore statement if I want. The y-intercept equals 0, 5. 1, 2, 3, 4, 5. And again, I can connect with a straight line that goes through my grid with arrows to indicate that it extends forever. So sometimes it might be more efficient, especially if we have an equation in the form ax plus by equals c. It might be more efficient just to use this intercept method. But again, I always could, if I wanted to, I could have rearranged this equation. So why don't I just show that here? I could have moved the 4x onto the other side and then divided everything by negative 2. So I would have had y equals 2x plus 5. So I could always rearrange in y equals mx plus b form, And then sure enough, I've got a starting value of 5, my y-intercept. I'm going up 2 over 1, up 2 over 1. So both methods will always work, and it's up to you what you think is more efficient. If it's very close to y equals mx plus b form, it's probably easier just to start your graph at the y-intercept and then use the slope. But you may find that it's easier to use the intercept method in some cases. And on your homework today, or as we kind of work through this unit, you might want to explore which methods you prefer when graphing lines by hand. And then again, we can always check by plugging in the original equation into Desmos to make sure that our line is correct. Okay, so that's all for now. And let me know if you have any questions.